It's
Whoa, new
hello.
layout. Who dis?
What?
In all this excitement, I forgot to bring my microphone over here. How do I sound?
Oh, you sound really good, Alan. It's the sound
Good.
I want to hear when I wake up.
Is it not already? I thought I was your alarm.
Wake up! That's
Hey, Andres. Happy Thursday.
Hello. Ooh, Thursday. Almost the weekend. Always ready for this live stream to get me through this Thursday. But
yes,
it's been a good week.
exactly
It finally rained in El Paso. So
Oh, really? I didn't realize it rained in the desert.
like every 6 months, but yeah, it does.
All right.
We were
And it's that
past
time
over.
then.
We were overdue for one. It took a while.
Excellent. All right. Well, last time we met was 2 weeks ago, and we spent a lot of time dilly-dallying with our pleasantries at the beginning. And we're not going to do that because we have so much to cover. I can actually go a little bit long today if you can, maybe.
I'll check my calendar in the meantime, but
but what we're doing today is we're talking about A2A protocol, which is agent to agent, of course, Alan to Andres or Andres to Alan. I mean, if we look at the screen, anyway. So agent to agent. And what we covered last time was the A2A servers themselves. And we talked about how you can build an agent that communicates with, whatever it does, that really follows that protocol strictly. And we skipped over the client completely. And today we're going to be talking about the client, but we're also going to be talking about some expectations, I would say, or maybe some assumptions that I made about the protocol that I was rudely awakened to that were incorrect when I was going and building this code for today. Really excited about that. But first, before we do that, Andres, why is this layout so different?
Because we like to have fun. No, we're adding a theme to all of this. So I guess we've never introduced this program or this live stream as what you and I call it, which is null check, which you can see now up here, which is our show, Null Check, with your hosts, Andres and Alan.
That's right. Believe in Serverless officially has a spinoff, and it is this show, Null Check. Null Check. Null Check, of course, being a computer science reference to checking for the absence of a variable assignment or value. That's exactly what we're doing with this show. Is we're doing that for knowledge. We're checking for null on usually bleeding edge topics, typically in AI. So very cool. I'm excited that we're finally spinning off and doing this thing. So shall we get started?
The copyright. I love Andres to Alan. We should copyright that, Alan. Maybe we make some money.
Yes, because people say it all the time.
Yeah. Cool.
Okay. So A2A. We covered in our last episode what it is to build an AI agent that adheres to the specification. And it was a lot. And if you remember last time, I was griping a lot because the protocol kept changing a lot. And it's still doing that. It's not changing as much and it's not making as many breaking changes. So I feel like we're pretty good to plant our
Stabilizing.
flag. Yes. Um, so today we're going to be talking about end-to-end process and actually seeing it work. Now, one of the things that I operated under the assumption as, because the website for A2A makes me feel this way, is that A2A magically makes agents communicate with each other. That sounds like a reasonable assumption, right?
Yeah.
Yeah, we did an episode, I don't even remember, probably in April, for the multi-agent collaboration where it was the office and we had Michael Scott and he said, I want to make a party, and everybody did their own thing. Multi-agent
Yeah.
collaboration.
It just
That's
knew
what
about
I thought.
everybody and
Yeah.
took care of it, right? In Bedrock.
Yes, exactly. And that's what I thought A2A did. I thought A2A was this elaborate and standardized multi-agent uh, communication or collaboration framework. Or I guess technically it's a protocol, but either way, it's not. It's not at all.
Yep.
And I was extremely upset when I was sitting here in the dark one early morning trying to get that all working. I implemented a client. I was like, okay, now how on earth is it going to do chain of thought and make a plan and everything? Well, it's not designed to do that at all.
Unfortunately.
So
Yep.
the client itself. Let's talk about the two main pieces. We have the server, and I've already said several times. The server is basically the agent. That's the one that
Yep.
does the work. And then you have the client, which really all that does is format JSON RPC and parse JSON RPC and sends it over to an agent URL. That's
It's
it.
like an API, typical API, client server API.
Yeah. Yes. So that's really frustrating because I was building this giant MCP server farm so we could have a multi-agent collaboration example. And
Can
for a
we
lot of
call it
people,
agent? Is it an agent farm now, or is it still a server farm?
oh gosh, I mean, I guess we could call it an agent farm. I guess.
We'll copyright that too.
Uh, man,
Sorry for
totally got me on that
I
one.
made you
Yeah,
lose.
that's okay. That's all right. That's all right. I will get to code eventually. I promise. I'm just trying to set the stage a little bit. Um, I was building all these agents and I wanted a way to basically have a single entry point that knew about all of the different agents that I had and was able to just farm direction out to all of them. Well, A2A by itself doesn't really do that. There's a layer that sits on top of it that kind of runs that. Um, and the communication part really is A2A. I wasn't satisfied with that, really. So I built it. I built the abstraction on top of that. And that's what we're going to look over today. But before we get into code, I drew a nice picture. It's been a while since I've
Oh,
drawn a pretty picture. And
by hand, right? I know
I,
you've drawn by AI, but not like
yeah,
actually drag and drop
no.
some pieces.
Yeah, I
Let's see
drew
it.
one in Excalidraw. So it's been a
Nice.
while since I've done one there. Now let me bring it up real quick because it's important to set the stage for what we're going to be looking at. Oh no.
There we go.
Okay, let me resize this a little bit. Boom.
Look at that.
Okay.
It's a
So
nice
what we're
looking
looking at
diagram,
here,
Alan.
it's what?
It's a nice looking diagram.
Thank you very much. I'll zoom in a little bit so we can actually take a look here.
Mm-hmm.
I've said this before. I use Cloudflare a lot for AI agents. And specifically with A2A, I feel like Cloudflare actually supports the protocol a little bit better than Lambda does. because the protocol allows you to either stream a response or get a request response back via a single endpoint. And
Dynamically, yeah.
Lambda, unless somebody can prove me wrong, I don't think Lambda supports that. Lambda can do either a request response or a streaming response in a single function, but not either or within the same function. But Cloudflare workers do allow you to stream or request response via the same entry point. And I actually built a lot of stuff.
Yeah, you've
Take a
mentioned
look.
some of this, but a lot of it is still foreign to me, so I'll be surprised as much as our viewers. So let's get it on.
Excellent. Excellent. It's not going to be easy to show this whole diagram in one go because there's just so much to it. So no, I'll say we. You get your name stamped on this too because we're talking about it together. We
Sweet.
built two APIs that manage my farm. For anybody that
Yeah, I
doesn't
don't
know
have a
me
farm.
personally, I do actually have a farm. I have a quarter acre dedicated just to garden, and I have 60-ish animals on the property: chickens, turkeys, geese, guineas, goats. Yes, recently 4 baby goats, which is very fun.
Oh, they're so fluffy and
Yes,
cute.
yes, they are. Okay, so what I did is we built 2 APIs. One API dedicated strictly to garden management. And garden management, what is that? That's what garden beds do I have? What are the harvests that I'm pulling out of that? What are the observations that I'm seeing on the plants? What are the actual plants that I have inside of my garden beds? And what are the seeds that I have available? What's my seed catalog? As a gardener, any gardener would know, you get way too many seeds and you never plant hardly any of them. So we
Unless
built
it's
an
me
API.
and you just dump them all in the same planter. So not the way to go. But
No, it's not. But this is not a show about gardening. And
yeah.
so what I did, that API has something like 28 endpoints. And what I
Whew.
typically like to do is create an MCP tool for each endpoint. Makes sense. And that's too many. That's way too many tools for a single MCP server. We can go into the reasons in depth at a later point in time, but I'll just say at a high level, we don't have to go into it. Once you get 20 or more, LLMs actually have a hard time figuring out what's the right one to use.
Oh, really?
Plus, you're
Okay.
paying for all the contexts, and it's a whole lot of mumbo jumbo. So what we did, what you and I did together, Andres, when we were pair
Yes.
programming this, is we split these endpoints up essentially by tag. And we created an MCP server for each one of the tags. So we have an MCP server for just the garden beds, for all the stuff that you have in there, for the garden records, for garden plants, and for the seed. So in a single Cloudflare worker, and we'll look at the code for this in a little bit, we have our API for the full garden bed, which is /API/ whatever the routes are. And then we also have 4 MCP servers, 4 remote MCP servers that basically have subdivided that domain up into single responsibility tools by tag.
Wow.
Which is very cool in itself. When I got that working, I was like,
Yeah.
oh my goodness. This is actually
Yep.
how I recommend breaking things up from a large API into MCP servers versus one giant server that has arguments that you passed in to scope down the tools. Just create little ones.
Yeah, and I
And
guess
then
one of the harder parts would become, I mean, in here you got a pretty clear separation, but in like I'm not that this is not real, but in, I don't know, like your enterprise API or something, breaking it up by, I don't know, even domains or CRUD or anything, right? That's where it gets tricky as far as the maintenance, but having that split is something we'll have to be doing in the future as things grow. And like you mentioned, LLMs don't deal well with large MCP servers or with too many
absolutely.
tools.
And now let's
Cool.
expand on that. let me put a pin in it for 1 second. I'm just going to real quick. We're not going to go into the same level of detail. There's also the animal API that's built in very much the same way. Here's the care, here's the registry, where they are, the movements and stuff like that. So built the same way, same exact thing. And if you can see over here, it's
Nice.
scoped to different databases inside of Neon, AKA now Databricks. So both of those communicate. I have scoped the permission sets to the individual workers based on the database that they're connecting to, which Andres has pulled the pin out. Really what we're trying to do with enterprise development is we want to limit that scope, limit that blast radius as much as possible. So we have our full API for the garden domain that can connect to the garden database. And then from within there, we have subdomains inside of garden that each one of these MCP servers has access to its thing. Now,
Cool.
on top of that, we have a different Cloudflare worker that hosts all of our agents that we made. Now, these specific agents, you can see I have the route for each of them in here. So it's ai.allenheltondev.workers.dev/agent/gb, garden bed agent. So you can talk to this garden bed agent, which follows the A2A protocol, and it connects to this remote MCP server, which connects to here, and really has scoped that domain down for that one specific agent only to garden beds. And we've done that for every single one of our domains.
Least privilege. Gotta love that.
That's right. So not only is it good for least privilege, it's also good for cost. I mean, like legit, it's good for saving cost, because if we had all of the tools rolled up into one and we feed that to an agent, you have to pay for the tokens for all of your tool definitions. So instead of sending in a single agent, let's say 50 tools split between these two APIs, where you're paying for tokens on every invocation for every single one of those, I've limited it down just to the tools that it has domain over. So it's actually a significant cost savings.
Yeah, and that's because every time you call it, it's going to do a get on all the available tools and then use that, right, in its context to then do whatever it needs to do, right? So
Yes.
clever
Yes.
and smart.
Yeah.
A lot of savings there.
And so each one of these agents that we have in this Cloudflare worker, there's 9 agents all served out of the same worker. Each one is an A2A server.
Okay.
And so it accepts the JSON RPC that's defined in the A2A spec, and then it can return either a streamed response or a request response out of each one of these. Now, each one of these, if you remember from last time, has 2 endpoints. Do you remember what they are?
It was there was a get and post, right?
Yeah. Yes. I mean, close enough. I'll give you credit for that. The get is the agent card. Now that's a huge part of A2A, the specification. So
Who
the
am
agent
I,
card
basically?
is, yes, who am I? It's the identification of basically everything a client or an orchestrator would need to know to figure out what can that agent do. We'll look at an example here in a minute. So it has the get, which has a well-known endpoint. It's this route here that we have /.wellknown/agent.json. It returns JSON. And then it also has the basically slash for a post. And that's where it accepts that JSON RPC message. And you can pass in different parameters inside of that message to make it behave a specific way.
Yeah, and there were several sections there for all the pieces that you need to provide.
Yes. Yeah, it has things like capabilities. Capabilities will say, does it support streaming? Does it support push notifications? Does it support some other thing that I can't remember right now? It has the skills, which is basically the summary of what can this thing do. And then it has within there examples. So you can actually say in natural language, these are the types of questions or prompts that you can pass to this agent that it knows how to respond to, which is really useful for our orchestrators that can actually go in and figure out which agent to call. Okay, so we have our 9 agents. each one of those connected to their very own dedicated MCP server. And then on top of that, I have one more worker, one more, and that's the orchestrator agent. Now, the orchestrator agent is just a regular AI agent, if you want to think about it as does it adhere to the spec or does it not? It's just a regular it's just a regular AI agent that has inputs the way I defined them. For developer experience, of course, because I love developer experience. But what it does is it uses the A2A client to be able to communicate with these things. So it can get past a bunch of these well-known agent URLs for each one of these agents. It can learn about what the responsibilities are for each one of those, and then it can decide which one of these agents do I need to call based on the incoming request.
But the burning question here is, how does it know which agents it can communicate with?
You're right. I'm going to get there in a second.
Okay.
That's the very next thing. But the thing that I want to make sure that I say, which was it was like a hard block for me when we were going to implement all these things. We're so good at programming.
Yeah.
Was, well, how on earth is this LLM that I'm prompting going to actually make that call? And it's with the tools, right? We're always talking about MCP and tools with actual code function calls. It's just using a tool. That's all that it is. So the tool can essentially wrap the A2A client object that handles all of the creation of the JSON RPC message and the parsing of the result. And then it returns that back to the LLM. And the LLM does its thing, whatever we tell it to do, and then back to the user. Okay, so we're taking the other pin out. How does it know what agents that it can talk to? I think I already mentioned this once. I built a wrapper around all of A2A because the specification that's coming out of Google right now is very targeted at stateful design. And do you and I like stateful on this show?
Oh, no.
I mean, it's fine, but we prefer stateless.
Yep.
And we don't, I don't necessarily think it makes sense to have a stateful agent because the majority of the LLMs we're talking to these days are serverless. We're connecting to them via serverless API calls. So let's make the agents serverless as well. So I wrote a wrapper around the A2A protocol. I actually just stole a bunch of code and didn't use a lot of their code and made it stateless by, and we just scroll down in here. Thanks for the tee up.
Yay.
Wrapping it with Momento. Now, for anybody that doesn't know, Momento is an infrastructure provider that is a centralized remote cache and event distribution system. And we use that to hold all of the information that these agents are using to communicate with each other. So things like tasks. So if an orchestrator says, hey, I need to go talk to this agent, then take that response and go talk to the other agent, and then go talk to a different agent, and then roll all that up into a single response for the caller, it stores those things in tasks. And that's part of
that's what provides
protocol.
that's what provides the stateless nature of this is whenever the agent needs the history, it gets the tasks that it already went through and all that, right? So it has the history. It doesn't have to keep it in memory, right? And you made it stateless by storing it here in the Momento cache.
Exactly. So if you pull down the A2A client libraries in either TypeScript or in Python, the tasks are going to be stored in memory on the agent that is running. So you really will fall out of scope as soon as you switch over to multiple agents. So we use Momento in that case to be able to give all of our agents access to the same repository for tasks. Yep.
Cool.
And also, we're using that.
So you mentioned that this is you created this abstraction, right? And this is all built into that abstraction, right? So,
It
or
is. Yes,
so
it
I would just
is.
need to provide my API key and a cache name, for example.
Yeah, yeah, and we'll look at that code. We'll look at
Yeah,
that
yeah,
code.
yeah.
And this abstraction, just a quick sneak ahead, so don't leave everybody that's watching. Uh, all this entire abstraction is provided inside of an npm package that is actually unit tested, which is rare for me. So it's something that you can just pull down and just use, which
Once you
makes it
deployed it
super,
past
super easy to
GitHub,
build these.
once you deployed it past the GitHub repository, people are going to consume it. So
Yes,
I'm proud
yes.
of you. Yeah. Unit tests.
Thank you.
Whew,
Thank
who would
you.
have
I'm
thought?
just so honored. Proud of us. This is not a White Claw, by the way.
I thought it was. I mean, it's fine. It's 5 o'clock somewhere.
It's not. Yeah, not here. Um, okay, so one other thing before we get to your answer, you said, how does that orchestrator know what agents it can use? One other cool thing that we'll look at when we're actually running examples is, as part of the spec, of the A2A spec, these servers will emit status updates. Is this the initial time I've seen a task? Here are the status updates. Here's the final. Here's an artifact that was created as part of this agent actually running things. It goes and it emits all of those notifications. And so we actually use Memento topics as part of this abstraction to do the emitting and to subscribe and push that over to observability tools. So without that, just with the SDK that you get when you install A2A-JS or Python, those again are local. They don't leave. It's very hard unless you have some deep-rooted observability mechanism that can do all of this chaining and following a task from end to end. As opposed to doing this with topics where we can actually see it's going to this agent, it's going to that agent, this agent's doing work, this agent failed, so on and so forth. And we'll look at
Which
that. We're going to
we
look at
showed
all of it.
a little bit last time, but there was the massive outage that prevented for us to show
Yeah.
that completely, right?
Yes. Yeah. When the internet went down
Yeah.
across the world when we were testing. Yeah. So we have that. We'll observe that. But here we go, Andres. In answer to your question, my good friend, how does the orchestrator know what agents can I talk to? Well, when implementing an A2A server, with this abstraction that I made inside of Memento, you can pass in a argument in the constructor that says register agent true. It's a Boolean flag that you can pass in. That will go into Memento again, which is a remote global data store, and it will just go ahead and add that information inside of your agent list. So whenever you go in and you use my abstraction in the orchestrator, it knows automatically to go to that agent list and then go and fetch all the agent cards out of there and feed that
Beautiful.
orchestration engine. Oh yeah. Yes.
Yeah.
It's lovely. So
So
there we go.
I'll highlight this. Will make you happy that you've answered the most
Which,
challenging question. It was around when we were at the bottom, right? The state and the task history and all that stuff, right? So
oh
keeping
yeah.
context outside of in memory, right? Which is kind of the thing that brings up the question: are people actually using it like in a real production workload just out of the box? The answer to me is no, because you couldn't just do it all in memory, right? You could, but it wouldn't be efficient. Would it be cost effective? Would it be uh, super productive, right? So with these, I was going to say little, but no, huge enhancements and add-ons to the protocol base, you get all of that now. And
Right.
kind of out of the box, you get a second box, which is the npm package, but open
I
both
would say that's
boxes
the
and you get
box.
it there.
That's the
Yeah.
box. Yeah. And of course, these are solved problems, right? There's load balancers that you can have that go across, but you run into the same problems you have that exist outside of AI agents, which is how do I synchronize state in a meaningful way? A lot of times people just go to a database. That's fine. But once again, you're just not going to be able to use the out of the box provider
Implement. Yeah.
from A2A. Just fine. And it just adds a complexity layer that you ultimately will have to own if you want to go and horizontally scale on your own a stateful agent.
Yep. Yeah.
Okay. So, Andres, or the audience, do you guys have any questions on the diagram of what we built before we actually go and look at the code?
No, you've answered my questions.
Time to look
We'll
at the
see if,
code.
yeah, let's jump in. Feel free to ask any questions. We'll pop them open and answer them as we go.
Yeah, that's right. Happy to do that. So, Andres, I will give you the privilege of deciding. Do you want to look at the abstraction that I built, or would you rather look at the implementation, which is basically everything that we were just looking at in this diagram? What would you like to look at first?
I'm more curious on the abstraction right now.
Okay, is there a specific part?
No. I
Okay.
want to see the I want to see it's the how it's handling the whole registration and pulling of the registrants and
Yeah.
the orchestrator level.
Okay. Yeah. Absolutely happy to do that. I'm gonna switch our views real quick, just so I can swap over to the appropriate screen.
Yeah, we're testing all these layouts and fun new things. So Alan is going to get all fancy right now.
I am. I'm excited to show everybody how proud I am of using my multi-camera setup. Okay, hold on. No.
Get the right scene. Get the scene. Get the scene.
There we go. There we go. Okay.
Now I'll
So
say
here we
camera
go.
2.
And here we go. And I'm gonna look toward the screen.
There you go.
Okay. All right.
You look, and I said it already. You look so tan in this camera.
I think this is actually my truer color right now versus the other color.
Wow.
Everybody's commenting. Yeah. When I was at Postman's conference a couple weeks ago, I got the privilege to meet Ryan Reynolds in person, and like the actor Ryan Reynolds.
So jealous.
And I walk up to him. He's never seen me before, but I walk up to him, and his first thing that he says to me is like, "Wow, you're tan." And it's like, how does he know? How does he know I'm not always this color? Like, it was strange. It was strange and funny, and I enjoyed it. But I am really this tan.
Did you give him a big hug afterwards and stuff like that? You know?
Yeah, pretty much. Okay, so Andres, you want to look at what? What first?
So man, now I'm just curious. I see cores in there. Just so many
because
things.
I did build this in a way where you can directly call these agents from a browser. And if you wanted, and you should, if you are calling directly from a browser, you should have cores in there. Yeah. So cores, this will allow you to, whitelist or allow list URLs and HTTP method types.
Cool. Yeah, and there's
the method types I override because when you're following this protocol, it's only these.
Yeah, you don't need more.
Yep. Cool. So like I said before in our last episode, this abstraction was designed in a way to have as few dependencies as possible so it can be used in environments like Cloudflare that run on a limited JavaScript environment. So if you use Express, which is what the A2A SDK is built on, it doesn't work. So this is
using Hono?
Yes. I'm glad you said it because I still don't know if it's Hano or Hono. I built it on top of that framework, which is basically dependencyless. It's like just JavaScript. So this is fully compatible with Cloudflare.
Cool.
And it's just structured very slightly different than Express. So you can see we have our agent URLs and then post. This is probably not the exciting part. We went over this last time,
Yeah.
Andres. So what do you want to see? You want to see what does it look like if I'm registering an agent?
Yeah. And that's on the other side, right? That's on the client, on the server. Yeah, which
It
we're
is
on the
server. We're
server.
actually
Sorry.
looking at the
Yeah, yeah,
server.
yeah,
We're
yeah.
looking at the server abstraction here. I don't actually know where that lives. let's see where it lives.
See, it happens to all of us.
Okay.
It's like I know I did this. I just don't know where I put it.
Yeah, it's in the index, which is the file that exports everything for the npm package. So when you're creating an agent, this version extends the A2A where we can set the default TTL and identify whether or not you can register an agent. So I have an agent registry class
Mm-hmm.
that is doing, it's so simple. And it's like, why didn't we do this before? Why is this hard? It's not. This agent registry class just has one function. It's called register. And all it's doing is it's pulling out the agent list, which is saved in your cache, agent colon list. It is a JSON array of the agent name, description, and URL. And that URL is the base URL of the agent, not the well-known agent card URL.
Yeah,
And so
yeah.
really it's just saying, do we already have that? Has this already been registered? This is an item potency check. And then we go and we cache, we update the list, and then we go in and save that agent card as well. So we don't have to go in and
And get
fetch
it
it
again.
via
Yeah.
the fetch. Yep. That's
Simple
really
enough.
all that's doing when you register an agent. Now this is going to live in your cache, right? So this isn't a global registry. This is for you. This is for essentially namespacing your agents down to limit your scope.
Yeah, I do see a
But
future where you have like a global registry like npm or Docker Hub, right? But for agents. But we're not there yet.
yes, absolutely. I mean, that's the whole point of A2A is to ultimately end up at that registry where people can just say, I want to communicate with the Airbnb agent. I want to book a hotel in Dallas because Dallas is great. And it just goes and it does it.
Yep.
So that's
Okay.
that's really what we want to get to. It's not there yet, but
Mhm.
that is what the A2A protocol is designed for. So that's agent registry, and that's internal agent registry.
Beauty. Okay.
Should we look at the orchestrator? Because that's,
Yeah. So
well,
now
before
we
we move
have
on to that,
something
yeah.
registered. Now let's look at how it's pulling and how it's structuring everything to then create to use it with your
Yes,
prompt, right?
only the new stuff. We don't need to go in and look at the actual implementation of the server because we looked at that at length last time.
Mm-hmm.
So now we can go in and take a look at this orchestrator, which is doing the work that I assumed A2A did, which is multi-agent collaboration. You give it a single prompt, it can figure out what it's going to do, and then it will go in and actually do it.
Yeah.
So with this, I am not smart enough to build an agent orchestrator. So I used OpenAI because they are smart enough and they did it and their stuff works in Cloudflare, which is really nice. So I export in this npm package an OpenAI orchestrator. So when you create one of these things, we'll look at the actual implementation. You have to give it your OpenAI.
Key.
There we go. OpenAI API key. You can optionally give it a model. It defaults to 04 mini. And then you give it your Memento API key and cache name. This one I actually had to add because of a limitation in Cloudflare. If you open up too many connections at one go, the worker kaputs. It says you're
Oh
doing
wow.
too many things and it fails. So initially I was just trying to load all of the agent cards at one time, which was
Blow.
9, right? From what we saw earlier. And it said no. So I added this optional param to limit that and do them in
And
batches. So I just,
is that the one that's defaulting to 3 on top in the constant?
yes.
Okay.
Yep.
Cool.
Okay, so this is really all that you need in order to create the the orchestrator is your Memento information, your OpenAI information, and then you can optionally pass in the concurrency limit. And when it does that, it will create an instance of the orchestrator class, and you can optionally register additional agents. So this is adhering to that paradigm where there are agents that exist out there that are the servers that are globally registered and they have their well-known URLs. You can add that in here as an array of strings, and it will
Yeah,
go and it will load the agent cards in the background.
I guess we can't tell Airbnb to register their server in our cache, right?
No. No.
Okay.
I mean, we could probably try. Really, all we're doing in that registration is saving a URL, and then it's gonna just load that URL. So we could. And then here's the easy, in theory, easy params to actually make it do something, which is send message. And again, this is the abstraction orchestrator. So this would be a plain text query. To use our farm example, since we built all these things for the farm, what's on my farm? And then it can go in and figure out, what do we do? So I have request response, and then I also have streaming method as well for the orchestrator. You can do a stream where you're iterating over the chunks that come out, or you can provide a callback as well if you want to do something in your own code. And then these are private. This is where it's actually loading the agent card out of the registry that we talked about, so it can feed the system prompt, which is long.
Oh.
Now, the system prompt, if anybody that's done proper AI engineering or prompt AI engineering, this is really where you make or break complex tasks, your ability to actually do this in a meaningful way. So this is what I am telling, or what the abstraction is telling OpenAI to do. You're an orchestration agent. You can call anything that you want. Like, we've given it one single tool, which is the ability to invoke an agent through the A2A client, right? With us there. And then we just give it, its full set of responsibilities. We tell it about the invoke agent tool, what we need to do here. And then give it some examples. We load the agent cards, put that in plain text. This is, again, the system prompt. And then we give it other information that is relevant. Here's today's date. Here's the context ID that the user optionally provided.
Yeah, this
cool,
is
right?
Very important step, right? And it's basically giving it all the information of what it can and can't do, so it stays within the parameters what you want it to do. Right. So what your expectations are. It's like talking to, I don't know, a team member and saying, hey, it's the it could be like the JIRA's acceptance criteria for an agent, right?
Can you still hear me?
It's a very different sound.
Yeah. So my microphone was unplugged.
Yeah, you sound far away now.
How does this sound?
Ooh, way better.
Yeah, back to my night DJ voice.
Yeah.
Okay. Night DJ. So dumb. Okay. So this is the big piece here to making the orchestration actually work, this system prompt. So we've given it very detailed instructions. We've provided it with a tool. If we look in here, this tool. Yeah. So this tool is actually creating an A2A client with the agent URL that it wants to talk to, and then it's going and actually doing the communication and then spitting that back out for the tool response to the LLM.
So yeah, the combination of giving it the registry entries plus the tool for invoke agent, it'll get the agent URL to then be able to do stuff with the agent.
That's right. That's right. And then it's actually using the protocol to do the communication via this tool.
Noise.
Okay. Now, are you able, are you, yeah, I'm turning, not looking at the code for a minute. Are you able to go a little bit long today or no?
Yeah. Yeah.
Okay. Excellent.
Keep going.
Good. I was trying to decide if I have to rush through this last 15 minutes. I don't want to rush,
No.
but I'll try to get through as much in our normal time as possible.
Yeah,
Okay, and look back
let's
to the
take our
code.
time. Woo, so fancy.
Okay, so this is the code, again, that is all baked into that NPM package that I was talking about. So you don't actually have to do anything here. Now, is there anything else, Andres, that you want to look at before we actually look at how to build agents on top of this?
No, I'm good as far as current knowledge to move on.
Okay, good. As an added bonus, and this was one of the iterations that I did on this project, I do have a local MCP server that can work if you want to use the client tool here, this invoke agent. So it's just npx memento A2A agent, and it will run locally. Now that doesn't running local MCP servers does not work in Cloudflare in workers because of that limited JavaScript environment. So that's why it's given a native tool to OpenAI. It's not actually using the MCP server, but I did all the work to make the MCP server work, so it does exist if you do want to use it.
Nice.
Okay.
Good.
Yes. Okay. I'm gonna switch us back real quick while I. StreamYard's cool, but there are some things that are not lovely. Okay. I'm gonna switch us over to the actual implementation real quick.
Yeah.
So what do you want to see first as I bring that up? Is there something, because if you remember that diagram that we looked at the very beginning, all of the code that implements that is in this repository we're about to work at.
So there is a Neon. Are you using the Neon MCP server?
No.
I thought there was. No. Okay.
I am not.
No, but that's okay. Just curious, but
for no specific reason. I haven't used it, but
yeah.
there's no reason why I wouldn't really. Okay.
Next iteration.
Yeah.
Camera switch.
Yeah. Okay. Let me shrink this down. Just the general layout. We have our data. So the animal API, garden API over here in these folders. Inside of here, you have the open API spec, which has all of the endpoints for this specific API. We can look at this in Postman too. It's a little bit easier to look at when we get there in a sec. And then here in the source, I've extracted, we have the data layer in here. So this is by tag again, the subdomain. This is where it's actually communicating with Neon. So it pulls the Neon thing out of here and then actually does the data layer things. And then we have our MCP folder, which is creating the MCP servers out of each one of those different domains. And I have this nice little abstraction here that says, here's the MCP server that we're creating, pull the Neon connection string out, then register the tools. Cool. We're not going to go through all those.
Yeah, we've built this, right? You just iterated and made it cleaner.
Yes. And what's nice, what's different about what we've looked at before is now I have this extra folder for routes, which is the actual API routes that we built that is using the same data layer the MCP tools are using. It's not actually wrapping the endpoints because I want to provide, and this was another session that we did, Andres, I want to provide responses from the tools that are optimized for LLM use versus human use, which is what we use the API for.
Yep.
So we have the routes that go to the API that use the same data layer that the MCP tools are using, but they are actually responding in a different way.
Yep.
Then we have our API that sucks them all in. Yep.
Yeah, and it's the remembering that an agent might provide more information. For example, when you're registering a seed, we were talking, hey, it could give you the optimal depth of which to plant it in, what soil, temperature, all the things that humans wouldn't do. An AI agent could provide that. So you might as well capture all that information, which is why you might differentiate between these contracts, right, that you're giving for your APIs.
That's exactly right. Yes. And then this is the last thing I'm going to show as far as the implementation of the MCP servers and API go. What I thought was a very cool feat of engineering, very minimal, but I felt like a boss when I was able to actually get this working, where I just import all the different MCP handlers, like the actual servers, import their base path. And then inside of my Cloudflare worker, I say if the route matches the base URL of the MCP server, route it to the MCP server. Otherwise, route it to the API instead. That way, out of the same Cloudflare worker, we get routes that say /API/ every endpoint that I built, or /MCP, and then the name of the MCP server. So super nice.
Automatically, it's a single handler that routes between both the MCP API versus the human API.
Exactly. Yes. So that's the data layer. I'm not going to look at the animal one because it's structured the same. For the AI agent, so if you remember from that diagram, we had the MCP servers, and then we had one-for-one agent that looks at those MCP servers. Inside of here, we have our agents. There's 9 agents in here that all roll up in the same way as we were just looking at for the MCP servers. So all of our agents are hosted out of the same worker. In here, we have a couple of things. This is actually the implementation of the server. So we're going to go and we're going to pull from the package that I wrote, Momento A2A agent. We're going to do create Momento agent, right? This is the implementation part of it. Where, okay, full disclosure, I made another abstraction in this code because I had to do this 9 times. So I made a I made a helper to
which is specific to the agent, the LLM, or is that the whites for Claude? Okay.
Yeah. Okay. So this is the agent. This is actually making an agent with the Momento wrapper using Claude instead of OpenAI. So it's using Anthropic to create Claude, and then it's doing its thing. So I'm giving it Sonnet 3.5 to actually do it. I'm limiting the tokens. And then just passing through the message. And then it's doing a little bit of translation from the A2A specification for messages, right? Because you have a task, you could have 20 messages based on the actual task that it's doing. It's going in and pulling that entire conversation, turning it into Anthropic's format, and then feeding that to that LLM, so it gets the context of what's going on and what do I need to do.
Okay.
So when it all comes down to it, let's bump over to here. What we're doing to create an agent that uses A2A and the Momento wrapper is we're passing in our cache name, our API key for Momento. We're doing the same thing with Anthropic that we did for OpenAI. We're passing in the Anthropic API key. We're giving it a unique system prompt based on the actual, you're a farmer bot. Based on the actual agent that we're doing. So I want different behavior in here. We're giving it the remote MCP server that we created. And then we're building that agent card, which is part of that A2A spec, which is what ultimately gets fed into the orchestrator. So you can see the name, the description, here's the URL for it. And then what can it do falls under skills. So really, this guy is scoped to creating and listing weight tracking and animal treatments. And then here's some of the natural language stuff. And these are the things that I say on, mostly a day-to-day basis to my wife. So I just wanted to give real.
You and your wife have very different conversations than I do.
Yeah, we do have pretty different conversations in our households. And then we have some more information here about Momento. How long are we going to keep?
Yeah, there's the cores, the register, the stuff we saw in the abstraction. Yeah.
Yep. And then we're going to build that Claude agent, which is just wrapping all the logic. And then we're going to export that out to /agents/AC. So that's going to be that shared path inside of that Cloudflare worker. Cool, right?
Yeah.
Easy enough.
So well structured. It looks so simple. That's how you've
I
made
love it and I hate it
it.
when you say that, Andres. I just
Yeah. It's happened every time, but it's
yeah,
the way it's working out, right? It's complex, but you find a way to simplify it where
yeah,
you even have an npm package for us
yeah.
to
There was a lot of
consume.
discovery in this one.
Yeah,
Yep.
of course.
Okay. So now the part that we didn't really cover last time. So last time we covered this kind of. It wasn't nearly this nice or as straightforward, but we did cover this part. So the new part is the orchestrator.
Yeah.
And so that is our last Cloudflare worker, which is just the orchestrator. Okay. So we import the OpenAI orchestrator from our package that we talked about
Mhm.
already. And we say, okay, if that doesn't exist, it's the same thing. We're just caching the orchestrator. Same thing that we did before. Do this cache name, get the API key out of Secrets Manager, get the API key for OpenAI out of Secrets Manager. I
Concurrency.
set the concurrency to 1. So it's a little bit slower. It's not that slow, but it is a little bit slower. And then I'm hard coding in just for the sake of this conversation today for our stream. I wanted to show these are the agent URLs that you can use. Aaron. These are the agent URLs. And you can see we just looked at the agent definitions that had the base path. So we had the
Yeah.
same worker / that. So this is giving this orchestrator all of our agents that we made. And that's it. Like really that's it. So we're configuring this, we're creating the orchestrator, right? Here's the configuration,
Mhm.
here are the agents it's allowed to use, and then this is the logic inside of the request handler. So when I actually hit the endpoint for this MCP server, or not MCP server, Cloudflare worker, it is not an MCP server. I'm sorry I said that. Get that out of your heads right now.
It's out.
We're parsing the we're parsing the request body, looking for the message, and then we're just passing into the orchestrator send message, and then we're
So
returning the response.
quick question on the register agent stuff, right? If you weren't
Yes.
providing those would be still pulled from the registry in Memento,
Yep.
right? If you weren't providing
Yep.
it there. Okay, cool.
Yeah. The registry actually uses a set, a JavaScript set. So you can't have an agent URL. You can't have an agent URL loaded to the orchestrator more than one time. So a set provides unique values. And so
Mhm.
if you have something already in your registry and you explicitly include it inside of that register agents call, it's only going to load the one time.
Okay. Okay.
Easy enough.
Cool.
Yeah.
Yeah.
So again, this really was for demonstration purposes. My stuff's already in the registry. I don't need this.
Yeah,
But
that's
because
what
I
I was
wanted you guys to
assuming.
see how it works, let's load it all up and do it. So just as a reminder, what we did to make a multi-agent collaborative A2A compliance agent, that was a lot of words,
Woo! Buzzword,
is
buzzword, buzzword.
create a
You need
new,
MCP.
yeah, with that communicates with MCP servers.
There you
That is serverless. I think that's all. I think that's all the buzzwords that we got.
Yeah.
We're just creating a new instance of the orchestrator. We are giving it its config. We are giving it the agent URLs that adhere to the server specification for A2A. And then we are saying send message, await send message. And we're giving it the natural language query that was passed in the HTTP request. And then we're returning the response. That's it. Hands free. That's
Yeah,
it.
that's nice. Right? As
Yeah.
even once we get to the point where we're consuming provided agents, right, that are A2A compliant from other companies, right? Twilio, or like you said, Airbnb, make a reservation or something like that. This is all you would have to do as far as communicating with that, from creating a multi-collaboration agent
That's right.
framework,
That's right.
call it whatever. But yeah, you just have to register the URL at that point.
It is. That's again the promise of the specification, right? I just want to be dealing with URLs and have everything else work for me. So
It's
that's
beautiful.
the point that we got to with that abstraction.
Yep.
So now that we're an hour into the stream, now we can
Whew.
actually see it work. What a setup. What a
Yeah,
setup.
my heart's
And to see
racing.
it work, I'm actually going to let you show your screen, Andres, because
Okay,
we talked about this before. We're going to use Postman to hit this.
that's why I wore my hat. Um,
Yeah, nice. Nice. Now, this is going to be, I'm going to say it now. This is going to be a very good indicator why you do not put multi-agent collaborative agents behind a request response URL, because this is not fast. It is not fast in the least bit. So let's
okay,
can everyone
my
see that
screen's
okay?
showing.
I think I can see that okay.
I can
Now, one of
do
the
a
things
few
that
more
I
clicks.
wanted to show that I
Ooh,
think is pretty cool as well, just since we're here and we have Postman open, there is a feature that's hot off the presses that if you're familiar with like Google Sheets or really any of the G Suite, um, or even Visual Studio Code live sessions, Andreas and I are connected right now to a live session uh, in
yeah,
in
and you
Postman.
know that with because of this little dot. There's
Yep.
live session.
You can see I'm typing
Like
on my machine. I'm messing up the request for Andres,
this
which
is
is pretty
nice.
neat. So yeah, we just click on the share icon, and then down you start a live session. You can do remote control for a specific requests. So we're both
Here's
in there
the
right now. We can work collaboratively on the body, on really any part of this request. So I can change the URL, which we did yesterday because we were looking yesterday and I had the wrong URL in there.
yeah
And then we were looking at the body. We can send the message. I can send the message on behalf of Andres. He can send it on behalf of me. We can look at the same request response. It's a really
yeah
cool way to work when everybody works remotely.
yeah, which
So,
is the world we live in.
Andres, what we have here, this is our orchestrator agent. This is the URL for it um, in Cloudflare, A2A on Helton Dev, workers.dev. And then all we have to do, we're going to do two things. We have this natural language message. And then in order to track this request through the system, we're going to add a context ID. And that
Look at
way,
that.
that's going to get propagated through all of the different servers that we have. It's going to get propagated through the entire life cycle of that request. And we'll look at that in a second because I have a cool
Yeah, and
visual tool for that.
this will be using the memento topics, right? If you remember the diagram at the bottom,
Mhm.
it will be posting the status updates to this context ID, basically.
Yes. Yeah. So it'll say this is the agent that's being worked now. Here's the message it was given, and so forth. We can look at that in a minute. But right now, let's do. I don't think I actually have any animals registered yet. So what are my garden beds? So as a reminder, go ahead and send this one, Andres, and I'll talk during the lengthy response. Um, what this is going to do is it's going to create that instance of the orchestrator. It's going to be given 9 AI agents that are all A2A servers. Each one of those agents has access to an MCP server, which ultimately contacts Neon in the back end. And this orchestrator is going to pick out what agent makes the most sense to field this question. Ask that agent, get the response back, and then give that back to us. So we do see at the bottom, here are your garden beds. You have left triangle bed, center bed, melon bed, butterfly garden, which is a gross undersimplification of my garden. I have so many more beds than that. But
But they're
the
not
cool
registered.
thing is, the cool thing is this agent that we're testing has no idea, right? It just knows what agents it's allowed to talk to, and there's an agent that's been scoped minimally with a minimal set of tools that
Yeah.
knows that answer. So uh, this OpenAI orchestrator knows how to do that. Now that's a single step. That's a single throw, really.
Hmm.
That's a
Yeah.
one shot. Let's do another thing. Let's change that message. Can you zoom? Oh, there we go. Let's make it do multiple steps.
Okay.
And let's just be off the wall with it. So let's see. Daisy the goat just had two. We'll do Rose. Rose the goat just had two kids, Acorn and Beacorn, which are
Okay, I didn't know
actually
those
their names.
names.
Yes, yes,
It's
and
creative.
Daisy had two kids as well. My other goat, Seacorn, and can you guess the last one?
D Decorn.
No, it's Marigold.
Oh,
But we named all the boys Acorn, Beacorn, and Seacorn, and then Marigold is a girl.
okay.
A little bit different name. Okay,
Yeah.
so Rose the goat just had two kids, Acorn and Beacorn, with Leaf as their dad. Also, I collected two chicken eggs today. So what this is going to do, let's go ahead and send it so we don't have to wait. Here, I'll send it from my screen.
Okay. Ooh.
Nice. What this is going to do is we have tools in there that are animal registry. So we have the animal
Mhm.
registry AI agent, which is going to register Acorn and Beacorn. And it also has a like a records tracking for the
Eggs.
animals. It's going to add lineage in there as well. So it's going to say Acorn and Beacorn have their parents, Rose and Leaf, and then it's going to go and hit from a different AI agent the harvest, the production, garden records or whatever it is agents, the third agent, to say, okay, let's add 2 eggs to the harvest from today. And it was given the today's date. So what's it say?
Look at that. I recorded the 2 chicken eggs you collected today to register Acorn and Beacorn and link them to Rose and Leaf. I need a bit more information for each kid. Species? I guess,
Okay,
yeah.
that's fair. That's fair. We didn't give
Yeah,
it really
yeah.
enough information.
Breed, sex, male or female, tag
Yeah.
number, if
The good
any,
thing
date of
is,
birth. Once you provide those details, I can create the records in the registry. It
yeah,
went and hit that MCP server and knows the schema and
mhm,
there's the required fields, right? So it knows it needs
that's right.
that. So now hey, give me that information. It's
Yes.
what a human would do.
Yes.
It's crazy.
Yeah, exactly. Exactly. So with that, I don't actually have right now, I haven't built in multi-shot prompting. So we would have to pass in some more information about the task and everything to give follow-up information. So right now
Yeah.
it's really
Okay.
only good for one shots and hopefully it can go all the way through. It'll come. But I only have so much time in the day to see
Yeah.
to build these
This is a
things
lot.
because I do have a day job. I do have a day job too. Um, so let's do the last piece, which is
Yeah.
the observability portion. So
Yeah.
we can
I want to see
actually
that.
go in and see all of the stuff. So I'm gonna leave your screen up for a second while I load up the
And
tracker.
hopefully we don't bring down the internet this time with that
Yeah,
status update.
yeah. Oh, that was us. We took the internet
I
down. Okay.
I haven't read the RCA, but I assume there's the
There was, yeah.
famous show with Alan and Andres did a postman request that
Yeah,
brought down the whole internet.
that sounds right. That sounds right. Okay. Um, So here's what we're going to do, Andres. If you can change your context ID to, let's just make
Yes.
let's make it Peter. He was the last person to engage with us on the stream. I am going to steal the screen from you.
Okay.
Let me make sure that it is going to work. Yeah. Hold on. No, wait. Let's kill the silence with some music. You know what? I am mad. I spent a decent amount
Making
of
a song.
time making a nice ambient soundtrack to go with our nice retro theme, and I completely forgot to start it. Man.
Oh,
All right, Anders, can you can you at least start that for
I
me
will.
so we can do it the last few minutes? It's called like retro lo-fi or something. To kill my debilitating silence here. I was underprepared for this.
I like the bass. That's why you have music to break the silence.
Yeah, appreciate that.
A little bit. There we go. Cool. Yeah. So, like you said, there's no like follow. So there's no way for this agent to know, hey, this is a follow up based on what I said, right? That's basically where we're at with this.
Say that one more time because I was distracted.
So we weren't able to follow this up. Like, oh yeah, here's the information. It would have to be the full message again with all the information, basically.
Yep. Okay, I'm all set up on my other screen. I forgot to add my API key into this request in Postman, so that was my fault.
Okay.
Let me share super fast. We're gonna do this guy. Okay, I know you can't see it. Hold on. Okay, so what we have here is a live feed request inside of Postman that's going to watch those messages that are emitted from our A2A agent. So like I promised at the beginning of this thing, with this wrapper, you get observability with your multi-step, multi-agent processing. And it's all collected over that context ID that you pass in. So we said Peter, right?
Yes.
Was it all lowercase?
Yes.
Okay. So what this is going to do is it's going to subscribe to that topic inside of Momento, and then it's going to use the Postman visualizer to basically track all of the emitted messages that go through that multi-step collaboration. Again, all completely A2A compliant. So I'm gonna go ahead and watch. So this is a subscribe. So Anders, you go ahead and start your thing.
Okay, so I'm sending that request. It's the same request, so we'll get the same response basically.
Yeah, that's a good one because it is a multi-step thing. So what this will do is as soon as those messages start emitting, they'll show up over here, assuming I didn't break something in my drastic movement. Here we go. Visualization.
Cool.
Well, that's one. I expected a whole bunch more.
It's still running, right? It just submitted it.
Yeah. Oh, here we go. Okay, so these are going to come in live as it's doing things, and we can take a look at a couple of them.
Yeah, there you go.
So it's continuing to send
it's
messages. It's doing a whole bunch of different things. Look at this. And so what's cool about this is you look at some of this JSON, and you can see what it's doing, right? Rose and Leaf had twin kids, acorn and decorn. That's what the orchestrator passed in, right? And you can see down here, this is the animal registry bot. This is the guy that is actually doing things in this metadata. And down further, let's go down to this one. I collected 2 chicken eggs today. So again, this is coming from that orchestrator, and it's going to the animal production bot. It's going to all these different things. So you can monitor this entire chain of thought through all of your different agents through a single topic. And that's probably it, right? I think it was just the 2. Yeah. I've logged your collection, record updated.
Like in a production, right? As a consumer, this doesn't matter that much, right? As long as you're getting the responses. But hey, you're troubleshooting, or you want to see the train of thought, right? Like you said, it's curiosity based. You have a way to observe all this and what it went through, right? And we did some of this with the Bedrock multi-agent stuff where, well, we tried to, right? And it's a little bit harder to know, okay, it went to the logistics administrator and it just ended there, right? So all this it's observability, right? Where it's going.
It is.
It's super helpful when you're building.
It is, and I would say it's not just for troubleshooting, good sir. There's a whole lot of value that you can get out of things like this, because really what this can do, one of the other benefits that we didn't talk about here, I'm going to switch us back to talking heads.
There.
One of the things that we didn't talk about as a benefit of splitting a large API into multiple MCP servers with multiple agents that are responsible for them is I can change the model. I can use different models that maybe are more optimized for the specific tasks in that domain. So watching the observability records come in like this really can help you see, how is it doing? Can I optimize the system prompts? Can I do I need to switch out the model entirely because it just doesn't get it? Things like that. It makes a really big deal when we're talking about cost optimization and really the performance overall. Because what we're talking about right now is fully autonomous AI agent ecosystem, right? All we said was natural language, and it went and did its entire thing, right? We didn't do anything else. We were completely hands-free. I think next time I would like to hook this up to an Alexa skill, and we'll just do it over voice. And
We've been talking about that
just show the types of things that we're unlocking with builds like this.
That's
So yeah, that observability is I think a really big deal. Yeah,
just the whole thing.
It's also good to see.
Still mind blowing, the capabilities we have access to now. With
Completely
this type of
agree.
stuff. It's just crazy.
Yes, completely agree. And so, talk about one more thing about the benefit of having that observability is we were like 50 something seconds in that request that we sent out to satisfy all that. If
the last
for
one was
whatever reason,
1 minute. Yeah, 1 minute 2 seconds.
Okay, that's a long time. You are not going to have a person wait for that unless you're stringing them along. I actually gave a talk on this last year at a conference about stringing people along with asynchronous workflows. If you're giving them updates, something is actually happening. It doesn't have to be exactly what's getting emitted here, but you can say, kind of like what The Sims is, you just gibberish and nonsense, but you can give them updates all the time that say, yep, now we're continuing this process, and people will wait if they have updates. But if they don't,
if you have meaningful names for the agents, right, like actually using like gardener and the animal care agent and stuff like that, you can say, okay, now talking to the gardener about your, you can, it's your progress bar, but kind of those apps that show you like funny messages. This could be like that, but it's like it's doing real things, right? It's talking to the gardener to figure out the status of, he's going walking the field to count the gardens, right?
Exactly right. Yes. Yeah. So what I would really like to do, like, what's the end state of this project for me in a real life scenario? And that's turning this into an Alexa skill, because I don't like typing out the natural language requests, honestly. I think once we get to a point where we're stopping messing with user interfaces entirely, then we're going to really unlock a lot of ease when we're talking about AI agents. So what I want to do is I just want to walk in, I want to go on my farm, do my rounds, whatever it is that I do that day. And I want to come inside and say, Alexa, tell the farm I collected 12 chicken eggs, I harvested 16 cucumbers, and I pulled out a dead squash plant, and I noticed that the tomatoes are looking dry. And that's it. And it says, okay. And then I can, if I wanted to, look at an app on my phone or a web page and have that information there. We can do that.
Yeah, just ask it these same things, right? It's like, how are my garden beds doing? Right? Do I need to tend to one?
Right. Yes. Totally. And then you're golden. And I think, we need more use cases like this, because what I see a lot right now when I scroll through LinkedIn or wherever, a lot of the AI agent use cases I'm seeing are stuck in the IDE. Yes, I'm making coding easier. That's great. That's not for everybody. That's not a general public thing. We just built something for actual farmers.
Yeah, you're going to use it. I'm pretty sure you're going to use it and keep building upon it to keep track of your farm and your garden.
Yes, but here's what's cool, right? We wouldn't just go out and build this. What we live stream has a purpose, right? We talked about MCP servers. We talked about AI agents. We talked about building APIs that are intended to be consumed by both humans and AI agents. We've taken all these lessons and really have culminated it up to what we just demoed today. So now we can finish that final product to have a voice control for everything. And then we already have the API that can surface all the data, right? So we can then go and use the API that we generated that's for agents and for humans and build a user interface on top of it that's the summary. And pass that along. Very cool.
So much. There's just thinking of like just for the garden and farmer use case, it's like now you can have like humidity sensors in your garden beds and keep track of that and then feed it into your system to say, hey, you need to water this, or hey, it's gonna rain tomorrow, just stop it. You know.
I saw
make it self. You don't need to worry about those things. It'll just let you know. It's nice.
Yeah, that's right. I saw the irrigation app that I use on my phone for watering the garden has API keys, and I was like, ooh, well, I could make that an MCP server and hook that up.
Yep.
Anyway,
the world is your oyster.
That's right. Okay, so that's it. We're a little over time, 20-ish minutes, but I feel like the overage is worth it today. There's a lot, super information dense. We went end to end with A2A. We talked about servers. We talked about the client. We talked about orchestration. We actually watched the observability pieces for going into the protocol. And then we looked at what I would suggest is a good way to structure your APIs and your MCP servers together, because really we're entering an age where that's what we have to consider now when we're building something new, is the API and the MCP server.
Yeah, and man, I want to encourage everybody to try out the NPM package that you've created. Give feedback. Hey, it's open. Maybe if you have any enhancements, open up a pull request, right? I always encourage this, but it seems simple enough for us to use, so you don't have to go through the sweat and tears that Alan went through these past 2 weeks.
That's right. I sweat and I cried, so you don't have to.
Yes. Thank you. Thank you for that. I'll still cry, but for different reasons.
Oh, okay.
No.
not touching that one.
Cool.
Okay, well, if anybody has any questions on anything that we've done, you can reach us pretty easily on the Believe in Serverless Discord. If you're not a member of that, believeinserverless.com/community will take you straight there. Also, LinkedIn. I don't really use X or Twitter anymore. It's, if you want to reach me on social media, it's on LinkedIn.
Yep. Same here.
Okay. Well, thank you, everybody. We need to do an episode on auth, so I think that's probably gonna be coming soon to talk about security.
Yeah, we've been hinting that one for a while, so it seems like maybe first Alexa, then we'll see getting proper authentication around all this.
Yes. Let's build our Alexa.
Nobody likes it. No, it's not as exciting, but it's necessary. So we'll dig into that one.
It is. So next time, multimodal, all of this. So we'll maybe add some support for images and voice, and then we'll do auth after that. So thank you, everybody, for attending. This was a great attendance rate. We've had over 100 for the majority of this session, so I'm glad everybody's interested. I hope we've inspired you to check it out yourself, and try the new feature in Postman too. I'm actually curious to hear what your guys' use cases are for what you would do for that. But again,
out a lot of features, so that's nice. I didn't know that was it's in beta, I believe, or
it is a beta feature. Yep.
But you saw it. It's you just turn it on and it's there, right? So if you're collaborating with your team, building APIs, it seems like a good feature to have if you're using Postman for sure.
Yep. All right, everybody, we'll see you next time. And thank you again.
Bye.